Let's solve this question from JEST 2014. Here we have a monochromatic wave which propagates in a direction making an angle 60 degree with x-axis in the reference frame of source. The source is moving at a speed v is equal to 4c by 5 towards the observer. The direction of wave as seen by the observer is to be found. So the situation is like this. There is a source of light which is a vehicle. Let's denote it by S prime. So this is S prime frame. It is moving with speed v is equal to 4c by 5 towards the observer, and when viewed from S prime frame, the light beam is making an angle theta with x-axis. Theta is equal to 60 degree. We will substitute it later. Now when viewed from S frame, so this is S frame, an observer outside. When viewed from S frame, the light beam makes an angle theta prime with the x-axis. We need to find the value of cos theta prime. Cos theta prime. If you resolve the speed of light along x-axis in S prime frame, then it will be equal to Vx prime is equal to c cos theta. If we resolve the speed of light in S frame along the x-axis, Vx will be equal to c cos theta prime. Now Vx prime and Vx can be related using inverse Lorentz transformation of velocity. Vx prime is equal to Vx is equal to Vx prime plus V divided by 1 plus Vx prime V divided by c square. Now you substitute the values. Vx is c cos theta prime and Vx prime is c cos theta plus V divided by 1 plus Vx prime is c cos theta times V divided by c square. From here cos theta prime is equal to cos theta plus V by c divided by 1 plus V by c cos theta. Now you put the value of theta. Theta is 60 degree and V is 4c by 5. Put these values. Cos 60 is 1 by 2 plus V is 4c by 5. 4c by 5 by c is 4 by 5 divided by 1 plus V by c is 4 by 5. Cos theta is 1 by 2. So we are getting cos theta prime is equal to 13 by 10 divided by 14 by 10, which is equal to 13 by 14. Therefore the correct answer here is option A.